y'all. How is everyone doing tonight? It's the wrong night again. What is going on? Let me tune down the music a little bit. There. Hello there, Quinmeister. Hello there, Sean. Let's see, is my audio working? It is. My chat is working. My camera's back in place because I used it to film actually in some other place, so I have to put it all back and remember all the settings. I think it's okay. Let's see here. Oh, Jacco Weiss was first, and then Nigel Young came in. And then Nico says second or third. And then they greeted each other. How nice. We're a bit early. Oh, yeah, you were about, like, yeah, you're a bit early. Will we get smoked tonight? I actually don't know. I've been feeling a little bit off today. I don't know. Sometimes you have better days. Sometimes you have worse days, I guess. So, we'll see what happens. If it goes up in smoke, that's the result too. Some magic smoke. Yeah, it's time for that. Oh, we haven't had it in a long time. And it's cheaper if it happens on a live stream than if it happens on our projects. That's for sure. But that's why we do the live streams, to prevent that it happens in people's projects. So, you know. Oh, Leon Voss is here. And, oh, CJ is here. Nice. Bitrip. Oh, good evening. And Fade to Black. Uh-oh. Can you not see me? Description wrong. What? Edit. No, I need to build a prototype for the QuinLED-Diff-Power Receiver-Mini. Join along. What's wrong with that description? What's wrong? Hello, world. Hello, the Pius Karthik. The Forbidden Setup stream. No. Title wrong then. Talks about analog boards. Intermit.Tech number 89. Soldering and... Oh, you are right. Ha ha ha. My bad. Building a Diff-Power prototype board. Oh. See, I told you I was off today. I totally missed that. I read over that a few times at least. Okay, well, that's fixed now, I think. I hope. We'll see. Wait, now my YouTube says 0 viewers. That can't be right. Let's refresh that. Something is only wrong if someone mentions the ultimate desk project. Yeah, who knows? Maybe at some point. Yeah, we can't succeed at everything. Oh, MSX Droid is here. Good evening. And Chris van der Heren. Noise. I'm gonna drink some, let's see if the focus is working tonight. Yes, some Fanta Zero Sugar Exotic Taste. It's funny, it says... Oh, let's see if the overview is working, because I changed lenses and did all kinds of stuff. Oh, that seems fine. It says zero sugar, but someone pointed out recently that zero sugar isn't actually no sugar. It's just a marketing term. And it's probably from the fruit juice. But still, I mean... That's not... Zero is not like... I mean, zero is a zero. These are zeros. 1.3 grams and even 1% is not zero. So, yeah. I thought that was stupid. Don't call it zero if it's not zero. But I guess marketing allowed it. Or, well, the government or whoever. 0 kilograms, but it's a 250 milliliter can. So I mean, By the time you finish the ultimate desk setup, you learn so much you have new ideas. Yes, and then we'll have all the boards to implement it too. Is Fanta from Coca-Cola? I don't actually know. Yep, that's right. So, what time is it? Oh, still 2 minutes left until the official start. So we launched the Diff-Solo yesterday, and that was pretty good. It got lots of views. I liked that. Just checking stock levels at Dr. Z's. Okay, you still have some. No, it's not sold out yet. We have plenty. What are those strips behind you? You mean these? Those are WS2815, so 12 volt, and then 144 LEDs a meter. Oh, I'm testing something interesting. I guess I should show you, huh? Oh, maybe not. I don't know. Hold on. Someone pointed out, can you specify which pairs is used for the Diff-Solo so one can use one Ethernet cable for multiple boards? Go to Quinled.info, Digital Addressable LEDs, QuinLED-Diff, and then there is an article called RS485 pinout for QuinLED-Diff, and then it lists the pinout for all 3 board series. There's an article for that. Oh, you grabbed your solos from Dr. Z's yesterday. Nice. I guess I should silence my phone, huh? Oh, there we go. The article released before the product? What? I don't know if the article was released before the product, but... That's true, CJ. So, we were talking about the strips on the wall, but I have these in for testing. Let me see how I should orient it. The other way around. These are SK6812 RGBW. It's still... No, okay. Oh, the text is both ways. But these are 60 LEDs a meter. Sorry. Single addressable. And you can even get them at 144 LEDs a meter single addressable at 12 volt RGBW. And they work differently than the WS2815s because I've been playing with them a little bit already. So they're a very interesting variety. They're not cheap, but they are interesting. And the epoxy seems to be sticking. Yes, so these are interesting. I think I like these. They'll use a lot of power, but they're still interesting. Yeah, but that's not for today. I will test them further and then add them to my power sheet. I'll probably link them somewhere. Maybe I'll make a video about them because they're pretty unique. To have 12 volt single addressable RGBW. They also have 5 kilohertz PWM. That's also cool. So, yeah. Hello, hello, says Merlin Shaw. Emil Bart's going to build a case mod. Okay. Very interested to learn more about Diff-Power. Well, that's what today's stream is about. Well, not really an information stream, but... Sorry. Something here is irritating my nose, it seems. Anyway, a few streams back, we built this guy. And this is the QuinLED data, still was called. since been renamed. Power diff also been renamed, but this is the sender one. So this takes in 55 volt, it takes in a data signal, and then it outputs 5 volt on either USB-C or this terminal plug here. And you can see some burn marks from when we had actual magic smoke during the live stream. But that has since been repaired and the circuit's been revised. But I thought I built multiple of all of these boards, but I couldn't find them, so maybe not. So we'll be using this one. And, well, then it sends out the 55 volt over 3 pairs. They're all individually fused with an auto reset fuse. And it also sends out a differential data signal. And then, also from the last time we built this, we have the QuinLED-Power Diff. The data already got removed here, but now it's even changed again. That's why these are prototypes. That one's yellow. Yes, this is a prototype. So here this went correctly. Anyway, this is a receiver unit, and this takes in the power, and then you can add a buck converter, one of these guys, one of these big guys, right? And so you can add it with posts like so. It sits on top. These wires loop in here, and then on the other side you have 3 times positive, 3 times negative, and the data signal that comes out, and broken fuse indicators, and the whole 9 yards. And then you can power all your LEDs with just this little single connector here. Are we drinking Tecate today? No, we're drinking this stuff, Fanta Exotic. And these prototypes worked well, but we've since made, or I have since made, changes. So sorry if my sniffing is annoying. I don't know what's causing that. Maybe we can burn it away with some smoke. Let me find the tool. The tool is here. Because we're going to build a new board that I actually haven't built before. And that is a Receiver-Mini. So while this is now called, so these are the new versions. This is now called the, where is it? The QuinLED-Diff-Power Receiver-Large. I still have Power Diff on there because it's cool, right? So this has all been updated and enhanced. And over here we can see lots of changes. We're using different terminals, so we're using smaller terminals than this, but they have the same opening. So that's good. That's what we're going to... No, we're not going to test it today because we're not actually building this one. I just want to verify something with this one. And there were some circuit changes. I moved partially to SMD fuses because I've finally been able to find those. And, well, I could find them before, but they were like $1 a piece. So that's kind of prohibitive. And there's all kinds of circuits added in here, but we're not going to build this one today unless I feel really energetic all of a sudden. I don't think so. So this is the receiver large. But if there's a receiver large, that would indicate that there's also a different size. What's up with my nose, man? So today, no, we're not going to build this one either. Because this is the updated sender. Not that much change, so we're just going to use the old sender. I'll build this some other time. We're going to build this one. So this is the, let's see if it's on here big. Yeah, the Diff-Power Receiver-Mini. And that's a new board we haven't built before. Will it run Crisis? I don't know. We could have a Crisis because this is an untested board. But this is if you don't want, well, let's get it again. If you don't want that size of a board. What aperture? Okay, yeah. Well, stop shaking. If you don't want this size of a board, but you want this size of a board. So this is like, well, I'm not going to say it's like 1/3, let's say, right? Because it fits in a few times. And later, I hope to add a receiver nano, but that will come in a second wave when these have already been released. So I need to work on things separately, because otherwise they never release. Hey, there's Philip. Yeah, I stream too many Saturdays now, that's true. So today we're going to build this one, the Receiver-Mini. And that one works with, oh, here it is, buck converters like this. And those also stack on top of here. If I did it correctly. Let's see if we can align the holes, because this is still, you know, first board. I think those holes line up pretty well. We'll see. So yeah, this is a smaller receiver, so it's also less powerful. Well, this one can do like 20 amps at 5 volt. This one can only do 6 amps at 5 volts. Now that's still plenty to run an LED strip. But yeah, and especially if you're doing 12 or 24 volt, it can actually do the maximum amount of power we can carry. So that makes this board very interesting. Now the first thing we're going to do today is one of the issues is this camera always shakes. Bigger the better. Well, that's where this guy comes in, and this also has power injection and, you know, all kinds of stuff. But where this one had a problem before is that I couldn't get the buck converter to sit on straight, because the holes were just misaligned. I didn't do it correctly, right? So today we're going to see if at least fix that, and then we're going to build and test the other board. Okay. Let's see. Okay, let's do one more. That's why there's 4 holes, because these are the mounting holes and also the standoffs for the buck converter. So let's do all of them, I guess. I don't know. There. So now, I mean, you know, you have 4 standoffs or whatever mounts you can mount the board with, but we of course want to mount our buck converter. So now let's see if this aligns better than the previous version did, or if it's still crap. I think it's a lot better. Oh wait, these screws aren't magnetic. That was a problem last time too. No, don't hit the button. I'm just gonna loosely thread them in. This seems to fit a lot better if this one goes in. Yes! Okay, nice. Okay. Okay, yeah, that's in enough. Okay, that's looking a lot better, right? So now this actually sits on straight and it doesn't twist or bend the board. These posts aren't screwed in, but it, you know, it rests on them, so it can't hurt to have them. And the idea is you screw in the buck converter before you, in these terminals, before you place it on top, so you don't have to reach. No, yeah, it can happen, because I don't have control over the XWST company, but this should be a standardized design, because they mention everywhere that it's a patented shell and blah blah blah. So I don't think they'll change it, but who knows? Now another thing I want to try real quick is adding the screw terminals here to see if those are still, well, screwable. That's a word. Oh no. Okay. I need oh wait, no. I think I need these. Yes. No, I think these are reverse polarity protected, Emil, but I haven't tried that yet. Oh, look at that. Look at that. Okay, so even if this thing is on top, you can still reach in there with your screwdriver and, well, screw them in. Or, you know, manipulate the screws. And that was the idea. Because the board is slightly bigger than the converter itself, so that you can still add wires to the outputs while the buck converter is on there. And on this side, it's under the... Okay. it's under the buck converter because, well, once you've added the buck converter, you don't need to access those screws anymore, right? Let's see if I got the height correctly this time. I think so. Yeah, they fit. That's a bit. How are you doing? Let's see if I can get them. Hold on. Oh, Kitty is saying hello. I don't have a kitty cam today, sorry. Let's see if we can twist this. Yes, okay. And put this here. And then twist this back. And then screw it in. Okay. I need to move this away. Yes, it's a tight fit, but that's okay. Oh, I can still move it. So once it's soldered on, that's perfect. Excellent. It's Saturday, so Kitty wants to join the stream now. Maybe. Cool, I like it. So you'll have 3 times positive and 3 times negative, which will be auto reset fused at, well, I guess you can see 5 amp, 10 amp, and 5 amp. And they have 3 grounds, so you can do, especially for 5 volt, you can do power injections and things like that. But yeah, this fits perfectly now. And these standoffs are also the exact right height. Now this isn't a, I mean, especially if you have it combined and merge and form, I don't know, power diff receiver board. I mean, it's not tiny. This is quite big. Then again, you don't need a power supply. So if you get a box where just this fits, like. Okay, we can empty this one there. Oh. But this is a little IKEA box. I don't know. I think this would fit. This would be bent like this. And then you just put it in here. Look at that. Of course, it'll depend how hot it gets, if that's a good idea. But, you know, you could always, I don't know. But yeah. Because I realized that's quite big, and the size of that board is especially if you want to do 5 volt with power injections and things like that, we are also going to work on a mini board. And that's what we're going to do today. And it's this guy. Alright. Okay, I need to get my screw terminal back. What, and bridge the hot wires with the metal heatsink with your screwdriver? Yeah, I guess that's possible. Although this shell, I tested it, this shell is fully isolated. So, we can quickly test that actually, it's a good idea. Because if the shell is isolated, it doesn't matter, right? So let's turn on the multimeter. Let's see if we have a network connection today. It's loading. Okay. Dead. What? Connect. Alive. Play. Ah, look at that. Okay. So we go to continuity mode. Oh, I guess I can share a secret. Huh? I bought a new thermal camera. Or I ordered a new thermal camera. And that one will have video out over USB-C. So I should be able to use that as a webcam in OBS. And then I can give you a proper overlay. Or it should be able to do it wirelessly even. So that's going to be cool. Sure, Menno, yeah, I'll share the dimensions and then you can print something, for sure. This needs to go back in here. Okay, we're going to test continuity mode. So this is of course oh, stupid camera, don't focus on my hand. This is of course connected, which makes sense. Now let's see if the shell is connected with the output. No, with ground. Come on. Come on. No. Other ground. Oh, it's wrapped around it. Nope. No. And then positive in? No. Right? Okay, so no, it's not connected. This one connected with so red, is that connected with yellow? No. Yes. Well, these grounds are connected, but they're making my life difficult. Yeah, not connected. Okay, yeah, well, these ground wires are connected. So basically, even if you would short one of the outputs to the shell, it's no problem because the shell isn't attached to anything, right? If you shorted one of the outputs of the positive and the negative together to the shell, I don't know how you would do that, but let's say you did that. Well, then there's fuses that will protect you. So, yeah, no, it's also not connected to board ground. So we still have this, and well, it's connected to the leg, of course. But then if we probe the ground here, it's not connected to this ground, right? Nope. So screw, leg, yes. Other ground, no. So I don't think that's going to be a problem. Yes, I will only be advising this brand, because this brand will be the only one that has the correct shell to have the screw holes in the right place. Now, I guess I could make multiple screw hole positions if there's another brand people would really like to use. But then I'd also have to verify all the stuff, etc. And I'm hoping to buy these in bulk and then sell kits or bundles or whatever, or you can add one if you want, or you can order it from AliExpress if you want. That's all fine with me. But at least, you know, I need to describe a viable package that I know will work. Well, you can drill your own holes, I guess. But, you know, there's circuits there. I've kept some space, but, you know. Music loud. Okay. There. Now it's less loud. Yeah, as long as AllNet shipping isn't too expensive. That is certainly a pain point still. We now have iOS S, but yeah, we're still working on that, let's say. So, or we are working on that, but yeah. So, okay, this design is all good, solid. I'll build a testing version, and then we'll see. Today we're going to look at this guy, and that one uses plastic buck converters. This one is for 5 volt 6 amps, so 30 watts, and it'll mount on like this. I guess we should test if that works. I don't know. So we'll dismantle this guy. So I guess we'll do that the same way. Now this board has lots of mounting holes, as you can see. So the Mini actually has holes on all 4 corners, and then for the buck converters, because I couldn't get them in the same frame. Or I'd have to make the board larger, I don't know. I thought this was better. So let's do that one. Oh, and then we had a problem maybe. I don't know if my screws are long enough. So let's see if I drop a screw in here. Of course, that's not a problem once I put this up for sale, because I can just get, oh, there, custom link screws. So that's not a problem. But good evening, James. It looks like I got these dimensions perfectly right. Cool. Well, I've mounted it in reverse, but that's okay. So this will fit. This will is it crooked? Maybe a little bit. There. That's good. And then you can still mount it down, right? Okay. So this board is part of the QuinLED-Diff-Power system, which will do data and power transfer over UTP cables to run your LEDs with a single cable. And like the other diff systems, that consists of a sender board, which is this guy, which we already pre-blew up and then fixed, and a receiver board, which are these guys. And we're going to work on this guy today. I really wish it wouldn't focus on my hat, but I guess my focus area is too big. I'm in the wrong area. Hold on. Oh, there it was. Wait, what? Set. There. Now it should focus on this thing instead of my hands. Yes. Okay, let's get our... oh, we need to do the whole shabam. So we need to... I've done this in a while. You guys think I do this every day? Partying every day. But I don't. So let's get the building board out. Cat 4. What? No, it's for Cat 5e. Oh, I can't fit it in that way. Oh, it almost fits. Oh. Yeah, so you'll have a single Cat 5e cable, which will have a data signal for addressable LEDs, and then power, and then it arrives in one of these boards, and that converts the power to whatever voltage your LEDs need, or well, you put the right buck converter on there that does that, and then you can run your LEDs with a single wire. Okay, I don't think Cat 4 is still for sale, is it? So let's see, is it this one? I never know with PCB boy. Because we need a stencil. What about putting the board on top of the converter? Okay. If you want, you can do that. But then what? What does that improve, Nigel? Nope. Not the right stencil. Not the mama. There. So this, I have all kinds of stencil. This is for the big guy, and this is for the small guy. Sorry if I'm in front of the camera. I'm not. That's good. Let's try and line this up. Something like that. I need more tape. I'm now the Oracle. Thank you, James. But I'm not the all-knowing, okay? You wouldn't want to play trivia with me unless it's about parts of electronics and LEDs and things like that. So let's stick this down a little bit. This is too much on there. No one's perfect, mate. No, I know. That's okay. Okay, that should paste it pretty well. Where's my pasting stuff? We need the spatula and the scraper. Paste and flux. Although, wait, how many tubs of quick chip do I have? I have 2 tubs here. Why? What's the? Oh, this one's dirty. Ew. So this one's 2305. This one's the new one, I think. And this one is 2205. Yeah, okay. So this is the old one. I want to use the new one. Okay, so we're going to use this scraper to scrape the thermal paste and this to put it in and out. Nice, you're kind of lazy. And it's going to be a pre-assembled board. Just stir this up a little bit. Oh, it's dried out a little bit. Let's see if we stir it up, if it gets better, and otherwise we can add some flux. It'll still work. There, that's better. Okay, so let's get some goop. Yeah. Cool. Getting deja vu from last time? What about what? About building the board? So I need to ball this up a little bit. Oh no, I'm wrecking the tape. That's okay. What do you guys think? Might be a little bit light over there. Yeah. Well, this paste is nearing a year old again already, so I generally use it for a year, and then I order some new, and once it becomes really troublesome, I generally stop using it. But more. Oh, now there's tape on my spatula. Thick paste. No, I already order my stencils thinner because otherwise it deploys too much. No. I often order my stencils in 0.10 millimeter instead of 0.12, so I get less paste on the board. Wait, no, yeah. The max length for the data line, like with Diff-Solo and Diff-Advanced, we tested up to, well, I say 500 meters. I think we tested 600 or 700. I don't remember. but up to 500 meters is no problem at all. Now for this, that'll be different, because every meter you add will add resistance, and thus you'll end up with less power at the end, right? So I'm probably going to do testing like, okay, you can get up to 75 or 80 watts at 50 meters distance, and then make a table like that, so you can decide, oh, my cable is going to be 25 meters, so I can get an effective 90 watts at the end. Something like that. But that's for power. For data, you can go 500 meters, no problem whatsoever. Okay, let's put this stencil away. No, we have to clean the stencil. I'm using very professional kitchen towels. Yes. There. So now this can go away. Yes. This can go away. This can go away. Good. We get our trusty working surface. Let's see if I can zoom you guys in a bit more. No. Well, I can digitally zoom. How's that? Whoop. There. No, these are still the old ones, because I didn't like the new ones from IKEA. I need to find different ones. The new ones were very flimsy and broke up easily. Okay, we need tools. So I get my trusty tweezers. I forgot the name. Okay. What do I do for a living? Well, nowadays it's this. I will always tell people for fun I'm a YouTuber. I am partly full-time YouTuber, so it's not a lie, but... and other than that, I've always done IT work, and I hobbied in electronics. And, well, that kind of grew into this. Let's see, where are my files? Power Diff, Receiver-Mini. Okay, let's turn that off. Let's see if I can find a way to show you what I'm doing in the BOM. Well, that's a bit big, isn't it? I think I'll put it over here. Is that readable? I guess not. That should be readable, right? Okay. So... Oh, no, I can't see myself. Okay. So we partly have new components, and partly it's coming from my stash. I haven't done this in a while. I need to get into it. Let's see. We need a 10 UF 16 volt 0603. So we need a 0603 capacitor. UF 16 volts. Oh, I have a 25 volt. That's fine. And we need 3. I'm not sure where you got that. Old school cover. Nice. I just now read it. But this has nothing to do with PoE. It does send power over the Ethernet, but it's not PoE. You can do it with PoE if you have a lot of money. So let's see how stable... Oh, I need to orient the board in the same way, of course. There. Let's see how stable my hands are today. Not too bad. Okay, that is this one done. Do we need more 0603s? We do not. Okay. 2.2 100 volt 1206. 1206. Okay. Over twisted pair, yes. 2.2 100 volt 12 volt 10. Okay. Right, this can go back here, and then we need some 0.1 16 volts 0402. Capacitor. Oh yeah. Let's see, 0.1 16 volts right here, and we need 2. Oh. So the max length is undetermined. For power, for data, let's say it's at least 500 meters. For power, it depends on how much power you need. I think, but this still needs more testing, if you keep it below 50 meters, you should be able to draw about 75 to 80 watts at least. If you go beyond that, however, it'll still work, but you'll be able to draw less watts. But I haven't fully tested that yet. But let's say at 100 meters you can only do 50 or 45 watts. So anything under 50 you should be able to draw max load. That's kind of the design goal. Let's say 1 UF 16 volts, 1 UF 25 volts, I'll take it. It uses 3 pairs for power and 1 pair for data. You didn't check the article, Philip. No, it's okay. You did not, honestly. Ah, see. Okay, so this is a big cap. We're going to skip that for now. No. I need another 1206. Why? What's different about this 1206 than the other one? Damn it. Damn it, damn it. Okay. Oh. What did I do here? I'm bleeding. I don't know how I did that. You've been busy removing a concrete slab for the last few weeks. Oh, okay. That's taking a while then. But I get that's a lot of work. Okay. Oh, there we go. Manual labor is not great for an IT guy. That is for sure. I would not do well with that. This one goes here. Okay. Oh. Bleeding on the job there, Victor. So these are 2 big caps. We'll place those in a minute. Let's move to resistors. 0402. I have 2 boxes for that, low and high. I know where they are. Well, I know where one is. Oh, well, I actually need that one. Okay. Because it's right here on my disk, because I use it to film. See? It's 5.1K. Lots of them. 7. Holy. Luckily I have like at least, well, I had 500 at one point, but now I have less. Okay. This will fuse the output side, but the sender board will fuse the input side. Because I feel that the source that is providing the power should be fused. So that if anything happens to the cable, it'll still be fused. Right, let's see here. There. Well, on full load, it depends what you consider full load. Generally, I say to calculate with 50% RGB white, and then you're talking about 30 watts or so for 300 LEDs. Maybe 33. And it doesn't matter if you're... I think that goes for WS2815 and for WS2812B, so 5 and 12 volt. So you could run up to 600 easily. Pretty okay, I think. Did I get them all? I think so. Yes. Oh. Please, yeah. There. Oh wait, why did I put the 0402 box away? I need many more. 24K. Now I need the high box. Don't know where it is. Resistor, where are you? Oh, that's what we stinked in last time. I have this separate box here for high stuff. I couldn't find it last time. So we need 24K. 15, 16, 18, 20, 28. What? Did I buy 24Ks? Could be. Now we have to check the bag of new stuff. So it's going to take a little bit. Oh, especially if they didn't label it again. I hate that. What? What's a 6p brick nogging? It's a little connector, but okay. What's this? Oh right, okay. Yeah. These. I'm not going to need these. Nope. We might not have 24K. I might have just forgotten to order it. Okay. That's okay. We can take our little book. Because seemingly I thought it needed to be 24K. They just think they know the product, yeah. So we have our little book of resistors here, so we can just browse to whatever we need. Maybe I chose a value that isn't very common. It's possible. Oh no, we got 24K there. Okay, so we need 3. That's why I have these books in various sizes. Okay. There. Okay. 24K. Oh, they'll go over there. Okay. There we go. Oh, you couldn't actually see that, huh? There. And you go away. Okay, now we need 33R, so that's from this box again. In contrary to the other boards, including the large receiver board, this will not have a resistor switcher. Because, well, there's just not a lot of room for it. I might see if I can fit one, but this version does not. Okay. Let's see, 3.3K. Oh, if you like the AN Penta, you'll love the production analog boards there, Mark. Where does this go? I am wondering where this goes. There's crud on my tweezers. There. So this one is kind of a tight fit. KaiCat was like, no! There is no space! Clearance issues! Alert! Alert! Alarm! And it was like, do it anyway! And that's how that resistor got there. Wait. We need an 0603. And is that a low or a high? 120R, that's a low. Get the AN boards out. No, we recently did that. Need to go here. Oh, I was going to say, I wonder why this isn't 0603, but I remember. Yeah, we recently did a whole live stream about all the AN boards, so. What do you mean? It's all in the hand. I always rest like this part of my hand and preferably even part of my arm on the on the table, and that's why it seems so stable, because the table is stable. Okay, we need some diodes. Diodes. Nope. Diodes here? No. Diodes here? No. Diodes here? No. Wait. What? Hold on. Oh, there's a box of diodes. We need 4. Okay. First generation pick and place. Let's put these in here quickly. Okay. And now we need the magnifying glass with the light, not the one without the light. This is the one without the light. Yes, this is the one with the light. Because these have orientations. I always forget, but I believe they go on this way. So with the stripe in the box. But you'll see when we take out the microscope a bit later that even my hands aren't as stable as they might seem. Stripe in the box, all the way around. No, we'll take out the microscope before we reflow it to make sure it's all in the right place. Poor little boards there, Monty. We're gonna watch it work or not work there, old school cover, and then we'll see. So we need some green LEDs. I should have a box of LEDs somewhere. Maybe. SMD LEDs. It's right on my desk. He is a robot. Oh! We've got the pink LEDs. I can't really. No, I can't. I need to verify. I need to verify if the output is correct. So let's do this one first. The orange over here. Now I need to verify that the. Yeah, Mr. Pink LED is somewhere in the bar anyway. But the output level per color of a LED changes. So if I put another color there, I don't know if it's too bright, or too dim, or anything of the sort. And there's some new circuits on here, so I can't really gauge what they'll do. Right. Now, it's always the question for these LEDs, does the green dot indicate ground or not? I believe it does. So we're going to put those to ground. I guess I could test that, right? I can test that. But I'll have to put it in my paste. I'll test it with another one. So I have one orange. Do I have more 0603s in those colors? I don't actually know. That's a good question. Yes, I should have. Because I have this little bundle over here with all kinds of colors and LEDs. So, Johnny's going to be pissed. Oh, yeah. I need a green one. 06. Is this green? Maybe. Yes. And I need a blue one. So let me get the tape off and then we'll test it. That's sometimes the thing that takes the longest, getting the tape off of these stupid reels. There. Okay, let's see if I can move everything on my desk to get those LEDs in the shot. Yes. I believe we're already in continuity mode. So if I check where green is over here, right? So if I put my black probe there, I put there. Okay, that works. So where the green is where the ground is. Yes, and this is green. Good. So let's move that back. Okay. Where did green? Okay, blue goes there. We'll have all kinds of colors on this board. Okay, so we did this one. We did that one. We did this one. And now we need 0402 green. I wonder if I have those. I seriously doubt. I must have those because I've used them before. Then I think they're somewhere else. Didn't you have those 3D printed things for that? 3D printed things? What? They could be in the diodes bin. Let's see. Because technically they are diodes. I don't think so. They are not in this diodes bin, but I have a second diodes bin because, well, who doesn't? A wireless data signal. Dig to go and wireless? No. So this is Zener's. Zener. Okay, it's not in this diodes bin. Let's see where I would have put it. SMD LED. Does that sound like a good box? Sounds like a good box to me. Oh! Bip Solar Bear. It's not bipolar, sorry. Bip Solar Bear says, what's the most rewarding project you've worked on? Whoa. That's a good question. Thank you for the donation. What's the best project I've worked on? Or the most rewarding? I think... I don't know. I have several that rate at the same height, I guess, because I really like the Dig Quads, for instance. That turned out really well. It's really popular. I really like the Dig to Go, but I also really like the Dig Octa. That's an awesome system where I got to redesign everything, because the Dig Udo and Dig Quad are kind of set in their way. They are what they are. But the Dig Octa I was able to start from scratch, so that was cool. But I also really like the new analog boards that are coming and the diff stuff. I can't really say that there was a most rewarding project for me. There's parts of projects, like, as I said, Dig Octa, I was able to redesign everything. That was cool. Dig2Go had a nice case and form factor. That was really cool, getting that out. Because it took a lot of work to get that done. But it turned out really well. And Dig Quad, because it's really well appreciated and well used all over the world. And, yeah. So, not one thing in that sense. Okay, I found my SMD blue transparent. I don't know what color that is. Red. Colorless transparent. Okay. How does that work? I have to have green. Oh, 0603 green. But I need 0402. Damn it. Orange. Yes, got him. Think. Yes. Okay, I need 3. I do love the button of the Dig2Go. Yes, yes, yes. So we'll have to do the same test with these. I can do it on camera, I think. Let's see here. So let me check and orient these all the same. I think this is correct. So this is 0402, so it's really tiny. If I do it like this, they don't light up. Okay. And they do light up like that. This one doesn't light up at all. Okay, so this one needs to be like that. This one needs to be like that. Okay, see how there's a lot less light on these than on the others? Just because they're green. There. So, now I know ground is there. I'm gonna turn this real quick. There. Good. Whoa! Bip Solar Bear. Yeah, Bip Solar Bear came in again with $9.99. I bought 3 Dig Quads and love them. Thanks for bringing those to the market. I always hate it when you want to buy something super specific and it's impossible to find. The Dig Quad filled that void. Thank you very much. I'm very happy to hear that. And we have placed some LEDs. And thank you for the donation. That is absolutely appreciated. Oh, we need some other diode stuff. And another red LED. Whoa. Let's use a different red LED. Because why not? Orange, green, red. Yes. 0603. 7 LEDs on this board. Yes, I want LED overload. So let's test this one again, but I'll do that off screen. Or off camera, I guess I should say. Oh, nope. It stuck to the tool and then it got turned around. There. Now I need to determine what side is ground. I think it's this side. Because I generally put the resistor that isn't there. Why isn't this resistor there? What? Oh, okay. No. This is a diode. Okay. Well, let's do that next. I generally put that on the positive side, so. Well, sure, if it's an RGB package, you could do all kinds of colors, but well, that's actually not a bad idea. But then they would mix together, and you wouldn't know the status at all. It would just be mixed color. Let's see here. Oh, well, where do I have that one? Is that a Zener? No, it's not a Zener. It's a what's that called again? Whatever. It's a different type. 404 WS. I don't know where it would be. Because contrary to belief, these boxes are sorted. I just don't remember how I would have sorted it. Yep, got him. Got him! And these are tiny buggers. So this is part of the broken fuse indicator light, so that if your fuse for some reason pops, you'll get a red light. And in this case, it won't have a fuse, it'll have an auto reset fuse. But I should have adjusted the circuit in thus way that it should still work. I guess we can test that later. So, because of the auto reset fuse, you can't really tell if the fuse is popped or not, because it, well, auto resets. And now, with this, you'll get a light that the fuse is now broken. Cool. We need some of these new guys. This is a test of a new LDO. It's supposed to output 5 volt up to 60 volt in, I believe. Let me check, Philip. Stupid tape. Yeah. Okay. I got the tape. Yeah, but then where would I put it? That's the question, I guess. Right? Because this kind of, you know, relates to this block over here. But I want these labels there. But in theory, if you orient the buck converter on it correctly, it lines up with the cable order, basically. So it would be hard to do it wrong. There. well, sometimes a component just doesn't want to lie straight, or you know, not on its back. Did I forget a diode? I did, huh? What's this? Oh, it's a PTC. Oh, okay. Okay, we need another LDO. Oh, it's over here. Okay. I'm trying to follow Philip, but I'm not sure I am following. Small question. Say, it's not an error, but assuming that people know they need 55 volt input and selectable voltage output, it might get confusing. Okay. What would be a better way? Can actually put this back here. I'm glad I can provide some entertainment on your rainy day there, Joey.
What are you afraid of?
That should be okay. And then we need a RS485 chip. Sure, okay. I haven't actually started a note article yet. Well, I haven't encountered any notes during building yet, so I will make one and then I will put that there. Okay. No, don't throw them on the ground. Do not throw the transceivers on the ground. Okay. Dips on the first one. I don't know if that's a good thing. Then again, I always have notes when I'm building, so. Now, which is pin 1? That one is pin 1. That's kind of the reason I do this, you know, why you build prototypes. To get notes and improve. There, a transceiver. And now we need a level shifter. We need so many components. Let's see, where would that be? I categorize that into serial. Oh, I can put these here. And that one goes over there. There. We're almost there for the SMD stuff, and then there's only a few through holes, so this can go back here. Now I know I need my SMD capacitors. So let's do that one first, maybe. Let's not. Let's do that in a minute. We need some PTCs. We need 60 volt 100 milliamp and 60 volt 50 milliamp. Okay. I think I have those in here, but I'm not sure. Let's see. I do, but it's a different size. Here's a compatible one. Yeah, okay. I probably have some others. Oh, this can go in here too. But I have a compatible one here that is 120 milliamp. That will do for both. And you guys like magic smoke, right? So better use bigger fuses. But for production costs, it's actually better if I could standardize on one instead of using two different values. But my component consolidation didn't happen yet in this step, so... If I can use one fuse value that is safe and works for both, it saves me as a pick and place spot, real spot, and thus costs less money. This is through hole in this case, okay, and then we need a big capacitor. 47, 680. What? No. 150. What? This is all wrong. It's not this box. I've confused myself. Yes, there are 55 volt supplies. That's actually a pretty common voltage, so those should be fairly easy to get. Wait, do I not have 47 UF capacitors? I do. It's the right size even. Ha ha ha! Who would have guessed? Yeah, in a previous Quin box, I actually showed off some 1000 and 1500 watt 55 volt power supplies, and here on my desk, but that's not for these boards, it's for an upcoming variant, hint hint. But for instance, here on my desk I have a UHP 500-55 from Meanwell, so that's a 500 watt 55 volt output, so it can do 8.9 amps at 55 volt output. But for testing we'll use the bench power supply, but yeah. Let's put this over here. Without disturbing the other components. It barely fits, but it fits. It's good enough. Now this is later. This is later, this is later, this is later. Okay. Exactly, Pixel Party. That's the idea. You can just run 1 or 2 or whatever, how many you need UTP cables there, and then that is data and power. You can keep the controller nicely tucked away in your home. Yeah, no problem whatsoever. Okay, let's get the microscope out. So I'm going to remove this board. And now I should be able to one-arm grab the microscope since we did improvements. Whoa! Look at that. Look at it's one package now. It doesn't look like much, but still. And now I can just hook up the power adapter. To this cable here. And then I need the HDMI to over here. And that's it. And let's turn on the power. Oh, all the lights turn on, the camera turns on if I press the power button. And then in theory, if we do this, let's remove this. Why is this so big? No, wait. Don't need to zoom that one in. There. So, let's see what kind of job I did. What lights are we currently using? Okay, so let's see, let's start at the top. Wow, that is some good placement. Why is this twisted? That's not right. There. I don't understand. Ah, I do understand. My camera was on twisted. It's not really well locked in place. Okay, fine. There, better. Okay, those look great. That one can use a little nudge. That's fine. That should all be fine. I think that what's the most difficult thing about being a robot in a world full of humans? Well, then I should say emotions. But I have emotions, so you know. Oh wait, orient this light slightly different there. I think the microscope quality is really excellent. Even if I do say so myself. How about it? Let's reflow this, right? This should do well. I'll leave the microscope here so we can check with that later. I have a thingy over here. There. Oh, wait. What's blinking? What is this blinking? Oh, it's not really blinking. It's just the pattern on the milling pattern is confusing the camera, it seems. Okay. So I have a power cord here. Have you tried liquid solder? It's like solder mask. No. What would I need that for? Okay. So let's get something on there because it's confusing the camera. There. A Diff-Uno. Oh no, more board types. Sorry. Okay, we're heating to 155 degrees because I always use low temp paste. Did it already go out, Joey? Otherwise you could contact him to add it to the order. Ah, Diff-Solo. Yeah, I know. Ah, okay, little break for me. So solder mask is something different than solder paste. You haven't received an email in regards to shipping. Then I'd contact him on Discord. That's probably the quickest way. Oh yes, cooking class with Quindor. Wait. We can turn this thing on. This guy. Wait, where's the button? There. Okay. This is one of those air quality meters. Well, don't believe the values right now. It should go up. I guess I can hold it on top of it, like over here. Oh no, wait. Camera doesn't like that. Maybe I can do it like this. And then we can see when it's reflowed. Wow, you can even see the pixels. That's funny. Anyway, we were reflowing, so... Yeah, I know, Philip, I know. We're currently at 108 degrees, so we haven't missed anything yet. You can see the heat fumes. Oh, there he goes. Now I'm watching on the camera because it's bigger than in real life. We're at 138. That's the official temperature, so we need to go a little bit higher. This is also a 4-layer board, so it takes a little bit more. So let me do a quick inspection. I think I found one. See, now you need to have stable hands because you can't rest them. But I do a sort of two-handed trick. But I think most of it looks okay. No problem for a robot, exactly. Did you guys see anything that might be wrong? Turning the heat pipe off already. So let's get it to cool down a little bit over here. Okay, let's put that under the microscope. And then this a little bit out of the way so it will cool down. And let me get the microscope. Microscope. Ooh. Oh, sorry. Okay, microscope time. So let's put it in the orientation we just had again and zoom in. Whoa, there. Okay, there is a solder ball there. There. Oh, it went boing. Now it's gone. Okay, that all looks good. There's some flux yuck, but that's fine. This capacitor could have gone a bit better, but it's attached, so that's okay. Oh, there's a solder ball here. Oh, over here. There. No, I don't use flux cleaner for my prototypes. That's fine. That looks good. That looks good. All good. This one's slightly misaligned. No, this one is slightly misaligned, but I mean, no bridges and it's soldered fine. All these LEDs are good. Okay. Oh, this is a different one. Also good. Yeah. Okay. Then here are the fuses. Those are good. Then this LDO. Yeah, that's fine. Here is another diode. The little tiny bugger here. but it's stuck, so that's good. These are done. Yeah. Black magic, yes. No, it all looks good, I think. Yeah, the big cap is a little bit twisted, but that's okay. Cool. Very nice. Can I touch? Oh, I don't have to touch it. We will now do the... You can't see... Oh, you can't see me. We will now do the manual soldering. Disconnect... No, turn off. Turn off. Okay. Disconnect the power cable. Oh, it's off. Okay. Ooh, disconnect HDMI. Disconnect power. And it's one-handed put away time. Nice. Very good. I like it. Okay, let's put the power adapter with it too. Yeah, those balls don't really matter. They can't really create a short because it would be very hard for them to touch multiple things at the same time. If there's like hundreds of them, maybe they might, but you know. Okay, let's gather what we need. We need an RJ45 plug. We need a 4-pin. Those I have over here. True, true. Bonus pin. Okay. Oh. Okay, so we need a 4-pin, so we're going to make that from two 2-pins. There. It's funny, when ordering the components for the PCB for production batches, I have to calculate if it's cheaper to buy a actual 4-pin or two 2-pins and then combine those together. And it depends on if I have more 2-pins on this board or in different designs. Because then maybe I can order 10,000 2-pins instead of 1,000 4-pins. Because I need 2-pins everywhere, in other places. And then it might actually be cheaper to order 2-pins instead of 4-pins. And sorry, I'm rambling. Okay. RJ45 socket, hold on. Okay. I wonder where I have my big capacitors. Do I still have them in here? I do. Actually, I want to use this guy. So this one should fit over there. And then I just need a PTC. PTC. We want more rambling. Okay. Let's get a... Okay, that's hot. No. No. Yes. A 60 volt 5 amp. As an accountant, I approve of this analysis. Nice. Yeah, once scale goes up, those things start to matter, because that's where you can save cost, basically. And I often get a lot of things custom, because, for instance, on the screw terminals, let me open this one up. On the screw terminals on the Diff-Solo, for instance, you'll notice that these have Phillips heads. That is a custom order, right? So we custom order 2-pin and 3-pins a lot, and I can also make other variants with that. Yeah, because I like Phillips head screws a lot more than this flathead type. It costs a little bit extra, but yeah. Oh, I had to replace its brain. It was brain surgery, Philip. So that's how that happened. It's all about the margin in the end. Well, not so much for me. I mean, I have to make profit, right? But I'd rather keep the same price and then lower costs than not do the effort and have to raise the price to get the same margin. So I don't need more margin. I just want to keep the price down. The Allen head screws. No, I like Phillips heads. They're my boards. So that's how it goes. So let's see. This should just plug in like so. Ha! Snap. Okay. Now the question was, will this be able to fold flat once it's on there? Oh, it's not enough space. Well, it might be flat enough. This capacitor is in the way though. See, that's one of the things I can't really see in my CAD software. Now what if I did it like that? Yeah, not really. Yes, those are more expensive, but guess what type these are? That is what I'm using on the newer boards, Joey. So, let's see, how can I get this on here? This capacitor might need to move out a little bit, I guess. Because then, let me screw in, yes. Let me solder in the screw terminals first, and then we can see. I don't use Allen head screws. That's my issue with them. Yeah, that's true, Joey. But they are more expensive. But I am trying to move towards them. Another problem is that I often can't get them in color. And I like having colored terminals to explain what they do. But we're trying to find ways, and the more boards I use that type on, the more I can buy in bulk, and thus that makes more things possible, right? So, yes, we've got the nice and beefy tip. Let's turn on the soldering iron. So over here, let's solder data. solder buck input. Oh. So the idea on this board is that on the output, the labels would still be visible in front of the screw terminal, right? And it needs just a little bit more space, I think. I mean, it's legible, but it's not really readable, so few millimeters. Oh. Good. Yep. So let's do the legs for the RJ45 socket. Let's see. Yeah, they're okay. Good. Okay. So we have the capacitor left and this fuse. What about if we put in this fuse first and, I don't know, jam it against these terminals? Can I then put the capacitor in? Oh, I could actually use the different spacing. Nope. Okay. No, I can't use the different spacing either. Okay. So, I guess that works. Yeah, that would work. In the end, I think... well, it would fit. I mean, the footprint, this custom footprint allows for everything. But in the end, I might make the board slightly wider. And that would solve all issues. I mean, like 5 or 10 millimeters... 5 millimeters isn't gonna, you know, ruin anything, so... Okay, so let's solder on that capacitor. Okay, that seems to be on straight. I always like soldering both holes. It gives a little bit of extra. I just have to check the orientation, but that's correct. Okay, let's snip those legs. Snipping while it's still hot. Lay the PT flat on the back of the board for now. No, we can make it fit. That's okay. I mean, if it's like this, that's okay. It's touching this terminal, which I'd rather not have, but you know, I can update the design. This is, as I mentioned, this is one of the hard things to figure out without having it in front of you. No. Okay. There, that should keep it in place. You can use these. I've never stripped them, but okay. Ow, it's hot. There. What if you connected a Diff-Solo to this? Well, you wouldn't believe it, Emil Bart, but then you'd get data, and that's it. You'd get data. Oh, well, the board wouldn't power up, sorry. Because it's meant to be powered by the RJ45 socket. But if you power it directly with the... well, I think you need buck in and out terminals, because it depends on which parts of the board you want to drive. But let's say you put a 55 volt power supply straight on here, and then also put the buck converter on there. Then it would just work. And I designed it in such a way that nothing would happen. It's easy to do as a bear. Okay. So this is basically it. We have our RJ45 input socket, which clearly says RS485. Not Ethernet. There's our diodes. They're like cramped in there. Those will get nice and toasty. So we'll have to watch this cap, how warm it gets. Our buck converter goes here. We have our fuse. And then it goes to the outputs over here with a broken fuse indicator. And then we have 3 LED lights here for power in, power buck in, power buck out, and power board 5 volt, because that's all different circuits. Oh, and over here we have 3 LEDs where we can see each pair on the UTP cable if they're online or not. This is going to be interesting. Wait, it doesn't have power yet there, Emil Bart. How can it explode? Okay, let's put my soldering iron away. Let's put everything away. Because we're going to assume we don't need anything anymore. It's just going to work. What's going on? It's not Friday. No, we had a video this Friday, so it's like, let's do a live stream because I had to build anyway. So now let's take the 5-volt buck converter and let's mount it on there. And currently the capacitor is the highest thing, which I hoped for. So that's good. I need to see how I'm going to do this. Plug in a PoE switch with forced and watch what happens. I don't actually know what would happen. As long as it doesn't send power over pair 1, we should be okay. And I think standard is pair 2 and 4. I'm not sure. How am I going to do this? Well, let's do... I lost 2 screws. It's really annoying. Oh, wait. I think I can make something work. Can you do a 24-hour live stream? I think I would die. I don't know. Okay, let's do the buck converter first. If they were Allen head screws, you wouldn't lose them so easily. I would, because I would never use them. Sorry. Okay, I'm gonna put some extra legs in here, just so the board keeps standing. And I don't have screws handy, so I'm just gonna use posts. Shouldn't matter. Oh, one of these is not like the other. It's probably an M2.5 instead of an M3. All these holes are M3. So. Okay, so now it can stand. That's nice. Wait, let's make this smaller again. Nope, wrong one. There. So, like so. There. Well, that fits pretty well. And I did it the wrong way around again. So it needs to go on like this. Because then the cables are at the side we need to cable in. And if we can see here, buck input is over here, ground, ground, and then buck... Did I do it wrong? What is output? Oh, no, I did it right. Sorry. Buck output. Hello? Buck output is over here, and yellow is also over here. Now you could shorten... I looped myself. I put the buck converter on without putting the cables in there. There. Okay, let's see how long the... Oh, that's okay. That's long enough. So you just wire it up exactly in the order that the buck converter is. Like so. And in a normal install, you could probably just shorten the wires, but... Let's see, this thing is... Oh, this is already in the second setting. I didn't thank you for the donation there, Bib Solar. Sorry. Thank you very much. That is appreciated. Okay, so now we have all the wires in, exactly in the normal order that they also come out. So now we screw the buck converter in. There, and now we have this little package here. Oh, for this one the standoffs could actually be a little bit shorter. That's because the other one is higher, this one has higher screw terminals. Yeah, that is correct. They say it's a 36 to 48 volts, but it actually takes 60 or 65 volts in, down to 30 volts. And that's what we need. We need a 30 to 60 range. Or it'll explode. But I believe most of them that I have are... Oh yeah, this one says 60. Okay. And this one says 36 to 48. That's the same. And then these say 30 to 72. Okay. But I haven't 100% settled on the type I'm going to use yet. They have multiple different types. Oh, this is a 5 volt one again. In the same form factor. So, which one is this? Oh, it's a metal one. So yeah, we'll have to see. Let me look up the order page just to be sure. So let's see, 5 volt 6 amps. Can I search for that? No. XWST, yes. So let's see here. Okay. So it's this module. You blocked the magic smoke again. Yeah, maybe. Oh, let me search if this is the right one. So you have to scroll down, and then you see that the 1 to 6 amp plastic module, and we have the L version. It does 20 to 60 volt input. So that should be fine. It has overcurrent, overvoltage, overheat, short circuit, waterproof, anti-shock, and anti-dust protection. Good. Very good. Well, now we have this thing, right? Let's bend these out of the way. Yeah, I don't know why they do that, but we'll see if it works. I mean, does it have glitter? I don't know. It doesn't have any LEDs. That's why I added a lot of LEDs to the board. Is this still hot? Kind of. Okay. Put it over here then. So now I need 5 volt LEDs. These are 5 volt LEDs. You want to see? 5 volt LEDs. Okay. Oh, it already has a connector connected to it. How nice. Oh no, I did it again. So I really should make this board wider so that just like on the other board, you can access this screw terminal while this is still on there. Right? Because now we prepared this like, okay, this is a module, so this is all prepared and done. But now I can't input the screws for the LEDs because this is under the buck converter. So if I make this wider, I solve the issue that I can't fold my fuse down, and that I now have to unscrew the buck converter for the 3rd time. So that will do. It will make the board bigger, but I could use a Phoenix style too, but I think in this case screw terminals are okay. Spirit animal. Also in this case you need to watch out. Hold on. This is not the normal order. This is VCC ground data. I could make a data in the middle, but I kind of don't like that order, because if you touch data to ground, that's no problem. But if you touch data to a higher voltage, well, that is potentially a problem. So I'd rather have them spaced further apart. Do you guys think that's an issue, or that's a good thing? In theory, you could mount the converter under the board, yes. So you could, you could move it from there to there, but I would advise to have some spacers there, because, well, this has all kinds of stuff sticking out, right? Well, there's no real problem. I know how people are with reading, but then it doesn't really matter what I do, so, I mean... Yeah, but you could mount it under the board if you want. But I would advise some spacing between the board and the buck converter itself, right? Because you don't want to push this or the bottom side into these pins here. You've had issues with sending 12 volt down the data cable. Yeah, exactly. So that's why I'd rather move the terminal so that if you accidentally touch the terminal next to it, you're touching ground and not positive. I thought I'd experiment with that. On the other board, on this board, it's completely different anyway, because you have 5 volt, 10 amp, 5 amp, 10 amp, 5 amp for positive, 3 times ground, and then another ground, and then data out. So the data is completely separate here, but yeah. Ethernet? Ethernet isn't. Maybe Cat5e, you mean? CJ? Okay, we need to prepare more setup. We need the diff sender. This guy. And we need to wire that up. So let's take a dig quad. I need to remove these screws. Or these power inputs. Oh. Nope. See, that's the wrong screwdriver. And this is the right screwdriver. You can get your Dick Quad autographed, that's fine. Unless it's a meeting I didn't agree to, then I'll take it away. Okay, so let's do power output from this board. Although this is the burnt board, so I don't actually know what parts of this board are still working and what not. I think it's all working. If you meet me while we didn't agree on it, yes. Okay, so, oh, and we need data in. Now, there is a ground terminal, 2 ground terminals here in the middle. This is for the sender board. 2 ground terminals in the middle, hence the white striping there. And then this is data in. Now, if your Dig Quad would be powered by something else than this board, or Dig Uno or whatever, you'd have to attach data plus ground. But in this case, since we already have a ground connection there, we only need to connect the data. Okay. This is wrong. I put the power on the outputs, not on the inputs. Actually didn't screw these down, so. Okay. So now we have power going from this guy to over here. So now we need power on this guy. And, well, there's a little problem. My cables from my variable power supply are fork terminals. So we're going to bodge it. What? I'm not going to suggest what's going on. So we're going to bodge it by putting this in 2 terminals, because they're both ground. That's fine. And then we're just going to stick this guy in here. And angle it up a little bit. Like so. And then there. Oh, see, that's why I hate flathead screws. Anyway, this is now in securely, so this shouldn't move. Shouldn't. So now we have power from my bench power supply, right? So let's turn that on. So I'm first going to turn this on without this connected to see if even this just explodes. Where are my safety glasses? I don't remember. What's the problem? Well, I'll lean back. Okay, let's zoom in a little bit then. There. Oh. So in theory this will work. But it's already a blown up board, so I don't know. We'll see. Let's set it to 55 volts. And 0.2 amps. But 0.2 amps at 55 volts. That's 11 watt. I think that's enough. Okay. Okay, I'm gonna lean back. Let's verify. Positive is in VCC, that's good. Then we have ground. We have a data wire coming out of here, that's fine. Then we have VCC and ground. That's red and black. That's also correct on this side. And that should make 5 volt. Unless it doesn't, because it's blown up. Okay. Power. Well, that wasn't spectacular at all. Okay. Seems to work. Yeah, VCC is basically the positive. So we have 3 green LEDs over here. We have an orange LED for power. We have the board power here, and the ESP is also powered up. Okay. Let's turn it off again. I need something Ethernet, huh? Let me get a cable. There. So this is a 25 meter Cat5e cable with standard AWG. Oh, don't push buttons. Where is it? There, AWG24. So this is a standard solid core Cat5e cable. You came here to watch explosions. Who promised you that? Okay, so let's put this over here. I don't know. I'll zoom out a bit. So this is now the whole setup. Is basically exactly the same as we just had. Annoying. There. Philip did. What? It's exactly the same as we just had. We just added the 25 meters of UTP cable. And we now have this guy over here. How do I want to orient this? Like this. Okay, so I can see all the LEDs. No, this is fed with 5 volt. So this board is making 5 volt for the DIG quad. Okay. Sure. Oh, well, all the LEDs are on, but I know why. So, we have the LEDs for the power out, and then we have the broken fuse LEDs on, and all of these are on. But that's because I have still limited the power to 0.2 watts, amps. So let's set it to 2 amps and hit power again. Okay, now the LEDs, these aren't doing the right thing because I haven't configured WLED yet. So let's do that real quick. Save. Good. And now it's orange. Let me give you a bit better view here. So here you can see all the different colors. I don't know about that yet. Green is too bright. Yeah, I don't know about that. These are now a bit brighter. That's good. These are bright enough. But this one's too bright, so I need to fix that. Oh, that also means the new LDOs are working. Oh, let's see how warm things are getting. I'll put on a little pattern here. Let's do blends. So over here, this board is okay. Oh no, don't do that. Over here is warmest. That's where the LEDs are, but that's why I changed the resistor values on the new boards. And I haven't built a new sender board yet. So over here, those are 45 degrees. That's okay. Don't like going above 50, but yeah. I don't know about that for that effect, Bip and Solar Bear. Yeah, RGB jacks, yeah, maybe. So, other than that, I can't really see anything getting very hot. That's good. Yeah, only the spot where the LEDs are for the incoming power, those are getting slightly hot. The different colors was to differentiate the three different things. So 5 volt being made, that's orange, because that's always orange on my boards. And then the buck converter output power and the buck converter input power. Oh, this is an S98 Pro from... Oh, I lowered the brightness. From Doji. Come on. Come on, you can do it. There. Yeah, from Doji. It's a Chinese brand. It's fine for the camera and everything, but I actually bought a new one because the problem this camera has is that it has, well, same as my camera it seems, a minimum focus distance of about, what is going on? About half a meter. And that makes it less useful for inspecting PCBs and things like that. My camera doesn't want to focus in, oh, there we go. Okay. Hey there, Cybucks. You would like all the same color. Yeah, maybe. I'll look into that. So far, nothing still is getting hot, and it seems to be working. Oh, it turned the stupid thing on again. There. Cool. So yeah, now we have WLED running with power through 25 meters of Cat5e cable with data and power. It's kind of boring if you look at it like this. And to prove that it's actually doing that, now the LED strip is off and the board LEDs slowly die. And if you plug it in, well, there we go. It's funny how everything slowly dies. It's probably because of the big capacitors. Yeah. Yeah, this is a prototype for the Diff-Power Receiver-Mini. I did not do that by Bip Solar Bear. It's not fun when everything works as designed. I might have a different idea about that. Yeah, that's pretty cool. So we can do a fun test. Let's do color loop. Okay, color loop is currently using 13.2 watts. Okay, so now let's disconnect this. And this is with 25 meters of UTP cable. So let's get another 50 and a couple block. Do we have any loose couple blocks? And let's couple these together. There. You don't have to buy it unless you want it. So, okay, now we have 75 meters. Yes, this is the power version of the differential single board. Yes. And let's plug it in. Okay, it still works. Oh, how much watts did I say we were using? I think 7.5, right? We're currently using 12.6 watts. So that's what adding 50 meters of cable does. So let's continue that. Let's see. Let's add another 100 watts. 100 meters. The 30 watt converter, Phil, it kind of depends on what kind of output you want. Let's say you're not doing any injections, then a single edge injection will do about 4 amps. And if that's bright enough for you, for the effects and things you want to do, well, then that's fine. So we're at 12 point something. So let's plug in another 100 meters. So now we're at 175 meters of cable. I don't know what you're doing when you need that, but okay. It still works. Oh, we're still at 13.2 watts. Okay, 13.7. Well, that's the max brightness then, I guess. 17, 18 watts. That's not much. Let's see what voltage it's running at. DC voltage. Of course, I can't reach those terminals. Let me try and make sure I don't short things out. Something like that. Oh, I need to turn the overlay on. There. Let's see here. I believe this is output. Yeah, okay, so the buck converter is outputting 5 volts, as expected. But that's good. So let's see what our input is doing. Our input is 51.06. Oh, well, 51 and a little bit, right? And that is over 175 meters of UTP cable. If I check the terminals on the sender board, that's 55.00. So from 55 to 51.1 ish. So we lost 4 volts on the cable here. That's not bad. That's fine. Yes, this can be powered by a single PSU, so you only need a 55 volt PSU, because the sender board makes 5 volt for the DIG quad. So you just need one PSU. Well, it's drawing 0.3 amps. I mean, exactly, Damok. That's kind of the idea. But I mean, I can try and draw solid white at 100%. That's drawing 25 watts. And then let's see here. We are getting... Oh, wrong way around. So we're getting 55 volts into the sender boards at 0.46 amp. And then we're receiving 49.4. So we're losing 5.5 volts at 0.46 amps. And that is being converted to heat. So that's a certain amount of watts that's being lost. That's being converted to heat that is heating up these cables. But there's so much cable that that amount really doesn't matter. And the sender board is limited to how much it will provide. So, yeah. Yeah, the Cat5 cable's fine with that, and the connectors are fine with that. That's all within specifications for those cables and connectors. But the trick is, it doesn't really matter what voltage arrives here, as long as it's higher than the buck converter needs to make 5 volt. So even if we lost 20 volt, I don't know, and we went from 55 to 35, this buck converter needs a minimum of 20 volt in. It's getting 35 volt in. So then it can make 5 volt at 6 amps, no problem. And if you're like, hey, but, you know, that's not enough power for me. Okay. So then you get the larger receiver board, which can do up to 20 amps of 5 volt. And then you have a 5, a 10, and a 5 amp output with individual fuses for power injection, because it's 5 volt, multiple grounds, etc. Right? Or you could say, okay, but I don't want to run... I don't want to run... What am I going to say? 5 volt LEDs. I want to run 24 volt LEDs. Okay, that's fine. Then get a 24 volt buck converter, which can do 24 volt 5 amps out, so that's 120 watts. Now this whole solution won't do 120 watts, but yeah. Should we replace it? Let's see what we have. I have another 5 volt 6 amp. Let's replace it with a 12 volt output at 5 amp. Yeah, this is not going to be... hey, it's Johnny! No, Cybucks, the actual specifications of these buck converters are 20 to 60 volts compatible. So that's why it works. Yeah, I'm not going to make a PoE switch version, but let's just say this is the sender 1 board, and there will be other sender boards. Let's just say that. Temp's still okay. Sure. Well, not for the LED strip. That's burning up. But let's check here. Oh, it did the stupid thing again. Okay. So the PTC is warming up. The PTC is 50 degrees, but That's normal because it's outputting about, let's say, 4 amps of the 5 amps it's rated for. So, you know, that's okay. That's normal. Then, of course, these LEDs are still pretty warm. Oh, you can't really see, can you? Those LEDs are still about 40 something degrees. That's fine. Over here, it's fine. And inside of there, well, it's only the PTC that's like 50 degrees. The rest is more like 30 to 40 degrees. We can look at the back side. The back side is about 40 degrees. Actually, the cable going to the LEDs. Here, the JST connector. Oh, wow, okay, that's a problem. The JST connector is 100 degrees. That's because I'm pushing 4 amps to the LEDs. No, this is Celsius. So the JST connector is at 100 degrees. So my board is like, hey, walk in the park. But the stupid connect... Oh, yeah. Oh, okay. Yeah. It is at 100 degrees. I verified it. Let's turn that down. I don't know if that's a compliment or an insult there, Johnny, if you're not sexting him because you're not drunk enough. I mean, how is he supposed to take that? Yeah. I put it on a different pattern, but this is 5 volt LEDs. Those don't get too hot, so they're okay. Yeah, the JST connector will start smoking at about 125, 130 degrees. But then you have to force it with something else than an LED strip. Because the limiting factor we just had was this LED strip not taking in more than 4 amps. So let's turn this off. Pew. Aw, LED slowly dying. Let's disconnect the 5 volt LED strip. And let's connect a 24 volt one. Okay, so we need to change the buck converter. It doesn't matter what you change it with, because the LED strip won't accept more power. So even if you change that to a 16 gauge cable, it'll still do basically the same amount of power, because the connector isn't the limiting factor. But yeah, if you wanted to run 300 LEDs and you're fine with a single edge injection, I guess you can run 175 meters of cable. And then it's okay. Where is the... Okay, here it is. So let's plug this in. And I need to put it upside down. There. Ah, I hate flathead screws. Okay, so now we've changed the output voltage of this board from 5 volt to... Well, if I can find my screws again. The JST connector, this cable is still a bit floppy. Where did I put the screws? What? Oh, they're still in the old buck converter. Okay. So we've changed this board from outputting 5 volts to outputting 24 volt. So if you wanted to use 24 volt LEDs, that's fine too. I could. It'll cost you 1,000 extra for 10 boards. If I can actually find screw terminals that have Allen heads. I don't even know. Nobody uses Allen heads except Americans, I think. Maybe, I don't know. Maybe in different industries. Okay. So now we're going to see the limits of the system. Because instead of 5 volt 4 amps, which is 20 watts, we can now do 24 volt 4 amps, which is 96 watts. I do need to get a 24 volt LED strip. I think I saw some over here. Yes, I think so. Is this 24 volts? Yes.
I'm not afraid.
24, yes, good. So let's unspool this one, because this one will melt. Will this work with the Dig2Go? No. Well, as a data source, yes. But other than that, no. Because you'll still need a 55 volt power supply. Right? So you could replace the Dig Quad here with a Dig2Go, that's fine. But you'd still need and you can feed it 5 volt too, because it has actually USB-C out. That's fine. So actually, yes, you could use it with a Dig2Go. But you would still need a 55 volt power supply also. So let's connect this. And no, wait, I connected 12 volts. Why did I connect a 12 volt converter? I thought I had a 24 volt. I do have a 24 volt. I connected the wrong converter. One moment, please. Oh, Philip already noticed. He's so awake. I think your internet isn't used to being on this late, Johnny. So, remove 12 volt converter, add 24 volt converter. Put it on its back, wire it in. Sorry about that, Cybox. Okay. Yep, those are in. Okay. 20 more hours to what? No. Let's see. Verifying connections. Let's bend these this way. There. Okay, now we have a 24 volt output with a 24 volt strip. This should be compatible with 55 volt. Let's plug it in and turn it on. Oh, that's bright. Now let me change the color order though. I think it's RGB. Wait, am I not in that output? Maybe it's not RGB. Maybe it's BRG. It's not doing anything. Okay. Can I change colors? So blue works. Red is green. Green is red. Oh, I know what I did. Okay. RGB. Yes. So now orange is orange? Yes. Oh. Okay, we're immediately drawing 28 watts or 0.5 amps. So let's go full power. Okay. We're now drawing 1.16 amps or 63 watts. Remember, there's 175 meters of UTP cable in between there, right? I mean, this can be like at your neighbor's neighbor house. Okay, so let's see. We have... Okay, well, we dropped 0.005 volts, so we're still at 55 volts into the power board. But now on the buck converter, we're receiving 41 volts. So we have 55 volts going in, and we're getting 41 volts. So that's a drop of 14 volts. And with 1.16 amps, you guys can do the calculation for that. So let's make it do an effect. Oh man, it's so bright. It hurts my eyes. I'm sure one of us will. I don't think it's Rob. Rob is not doing the calculations. $16 watt, yeah, 1.14, yeah. So yeah, now we're losing 16 watts in this cable, so it will start to warm up a little bit. But then again, it's 175 meters of cable, so that's 16 watts being distributed over all that length. It's not all in one spot. So, I mean, 16 watt over almost 200 meters is nothing, so that doesn't matter. And now we have, well, I can't really, I can measure how much amps we're outputting. Let's measure how much amps we're outputting. I need to change the camera back for that, because otherwise you won't be able to read the screen. We want, yes, no, not hold, light, there, and positive wire. Okay, so on this side we're outputting 1.4 amps at 24 volts. No, we're only doing 1.4 amps at 24 volts. And that's because this is now doing a pattern. So there's 46 watts going in. And we have 1.1, I can't reach my keyboard, sorry. 1.4 times, what's the input voltage again? No, times 24, that's the output. Okay, so we're outputting 33 watt as calculated by this meter here. And currently with this pattern, we're inputting 45 watt. So we're losing 12 to 13 watts. thermal value. What's that? In the connectors, you mean the couple block? Ooh, the couple blocks like these? Because the okay, let's move this away. No. Okay, too much stuff on my table. Okay. So all the power is going through this connector in theory, right? So this one, and that one is 32 degrees. So that's fine. The LEDs are hottest. And the back of the board, because it's been lying on the table, as you can see there, the back of the board is about 40 degrees. So that's okay. And then this guy over here, well, the PTC isn't doing much now. Oh, wait. Let me turn this stupid thing off there. The PTC isn't doing much right now. So that is only 37 degrees. The board itself is, well, about 40 max, 41, 42. That's fine. That's those LEDs again. Because those are, you know, connected to 60 volts or 55 or whatever's coming in. And other than that, I can't really see any hot spots on the board. So that seems to be functioning correctly. Cool. Now let's try and overload it. Because this converter can output 24 volt 5 amp. So that's more, that's 120 watts, says it right there. That's more than this is designed to handle. Now this still has the old PTCs, which are 750 milliamp. In the future revision, I want to move to 550 milliamp per pair. Because as you'll see, if I set this to solid and then white at full power, we're now drawing... Oh, we're current limited. Let's give it 3 amps. There. We're now drawing 121 watts from the power supply. And that's 2.21 amps. So that is more than I'd actually like to allow. The voltage coming into the sender board is about 55 volts. And the voltage we're receiving, if I can still see it, is 29.15 volts. We've lost 25 volts somewhere. 25, 26 volts is gone. It's gone. Yep. But the output... Oh, the output has actually dropped. It's too much. The voltage has become too low for the buck converter. So let's lower the brightness a bit. Why is this not working? Oh. It seems to have crashed. Is that possible? Can it crash? Yes, it did. Haha. My diagnostic LEDs to the rescue. Look at that. Although the buck converter is still working, it seems my 5 volt board power isn't working anymore. Although I don't know why. So let's unplug it. There. And plug it back in again. Oh, my board power still isn't working. Interesting. Why? Yeah, the LEDs aren't reacting to anything anymore. We blew something up. Well, something died. I don't know why, though. No, there wasn't any smoke. But if it's too hot, I should be able to see it. Yeah, there is a fuse in front of it. But I mean, it's not doing anything. It only got a lower voltage, not a higher one. Okay, the RS485 chip is a bit warm at 55 degrees, but that can still be okay. Did it short somewhere? No. Okay, let's have it cool down a little bit. Oh, now the board power turns on. What? Why? Oh, now it works again. That is a bit confusing. That's not how a product should work. Yeah, now my effect is also working again. Hey, my diagnostic LEDs work. I just don't understand how that would happen. Works for my tech support, yeah. I'm just trying to hot plug it, see if anything happens, but it doesn't seem to cause any issues. Okay. Yes, a fuse, but I refuse to understand. Yeah, I'm not saying it's aliens, but you know. I don't know. Oh, no, Bip Solar Bear. I wish all companies did R&D via live stream. Thank you. So I wonder what caused that. Let's set it back to solid white. Beam. Oh, there we go. Well, this is acting weird. Oh, this LED strip is not liking doing solid white. Can I? No, I can't turn it off anymore. Interesting. So if I put it on solid white, it's dead. Why? I mean, that doesn't do anything on the 5 volt side. It's not off, no. But I can see that the data coming in, it doesn't work anymore, right? The voltage on the ESP. No, because I can still connect the WLED, so that should be fine. Yeah, I'm wondering if I can measure the voltage the LDO is putting out. Let's see, here and here. It's still outputting 5 volt. Yeah, that's behind the resistor. This is also 5 volts. What? Why? That's not right. The buck converter is outputting 22 volts. It's confused. Well, that's probably because it's not getting a lot in. Yeah, it's getting 28 volts in. That's well below what it needs. Of course, there's 175 meters of cable in between. So let's turn it off. Okay. And now it works again. Yeah, that'll cause less voltage drop, because maybe the voltage is dropping too low for the buck converter. But it shouldn't drop too low for the onboard electronics, because that's run through the LDO and not the buck converter. So that's what's confusing me. But let's remove that 100 meters of cable. So now we're at 75 meters. Yeah, okay. That also just works. Okay. So now let's set it to... Oh, okay. I left my clamp meter on there. Let's set it to solid white. Oh, okay, it gets a lot brighter. We're using 2.2 amps. And what's getting in on the board? Okay, now we're getting 43 volt in on the board. Right, so the buck converter is well within range. And that shouldn't cause any issues. So let's measure the buck converter. And the buck converter is outputting a nice 24 volt. So maybe when the buck converter goes on the fritz, it somehow messes with the LDO for the 5 volt electronics. B, always B, Joey. A is old, don't use A. Yeah, so currently I think when the buck converter goes out of spec, it somehow messes with maybe in some kind of inductive field or whatever. And that, keeps it from working correctly. Because this now still works perfectly, right? So I can change LED modes. Let's turn it down a little bit. Yeah, that's fine. No. This is the LDO I prefer. Sure, Philip. But in theory, that LDO will do 5 volt to 80 volts. So although the buck converter shuts down, I don't care about that. The electronics should still be working because that's run off of the LDO. Maybe it just becomes too unstable somehow. Well, clearly it does. I just don't know why. Later, Emil. So I want to do one last test that might cause smoke. Let's unscrew this buck converter real quick. And I want to disconnect the positive wire that's coming out and see if that LED works correctly. Okay, well that turns off. Oh, okay, yeah. Turns off the LEDs. There's still a faint glow of blue there. Okay, it took a little while to turn off, but I wanted to verify that now buck input it works, because that's, you know, using the UTP cable. And then buck output is now off. Took a little while to bleed because, you know, of an output resistor or a capacitor. And 5 volt is also still working. Oh, and my broken fuse indicator is on because it thinks that, well, the fuse is broken because the LEDs aren't powered up. That's funny. Okay, so that works. So let's try and plug that in the right hole. Okay. Yeah, LEDs start working again. That's good. And this, yep, the blue light's back on. That's good too. Something else you might have noticed. We first had a 5 volt buck converter on there. And now we have a 24 volt buck converter on there. But the blue light remains the same intensity. Ah, magic circuits. Okay, let's disconnect the buck converter input. There. So now the buck converter isn't getting any power. We still have the 3 LEDs over here. Buck power in is still on, but I think it'll slowly die out. Yeah, it's decreasing in brightness. Our broken fuse indicator is on again because the LEDs aren't getting any power. I would have thought it would decrease in brightness faster. Is it still seeing buck in? Yeah, of course it's still seeing buck in. No, okay, this won't turn off because it's, yeah, I can't measure that. Okay, no, okay, that's logical. Okay, so let's plug that back in again. It's zapping a little bit. Oh, more zaps. This is good hot plugging. This is a hot plug test. Okay. You know, that's what real world people do too. Screw things in when it's on. Please don't do that. Yeah, buck in still had actual power, because although the buck converter wasn't connected, the terminal still had power, and that's the only thing I can measure. So that's my own snafu. I am not Merlin, no. Okay, well this works fine. So if you go completely nutso with cable, for some reason my 5-volt electronics malfunction, I'll have to do some scoping and other shit to find out what's going on there. But other than that, this is yeah. Also important, although we've limited the 55 volt supply at 3 amps with 55 volt, you'd expect sparks, but no sparks. Good. I'll think about the colors here. Might want to change all of them to orange, I guess. What happens when you short the Ethernet cable? As a last try, we'll short the output. So let me take the buck converter off. There, buck converter is off. I'll keep it in the shot in a minute. Hold on. Let me disconnect these wires. Oh, well, let's turn it off, okay. So, okay, I disconnected the LED strip because I'd like to keep that. There. I guess we now need a short wire. Let me look in my short wires box. This is in a very convenient location, not. Oh. This looks like a suitable size wire. And let's screw that into the positive terminal. Nope, wrong screwdriver. There. And let's screw it into the negative terminal. I'll zoom out a bit. The power supply is currently set to a limit of 3 amps. I'll set it to a limit of 5 amps. So it's allowed to input 55 volt at 5 amps. That's over 250 watts. And I'll have everything on screen here. And let's see what happens. Aw. It's, the broken fuse indicator is on very, very bright. Everything else is on. We're drawing 0.14 watts. It seems the protection circuits are working. Sorry, guys. So let's see what is limiting currently, because there's multiple things that could be limiting. Okay, let's see here. IR. Okay, on the board here are input fuses onto the UTP cable are not limiting. Okay. Over here. Oh yeah, okay. The 5 amp PTC we have on here is currently 128 degrees. So that one's not having it. That one's opened. So let's do some live there. This wire shouldn't touch anything. Yeah, sorry there, Keen. Okay. So what happens if I just poke the terminal a little bit? Oh, yeah, zap. Oh, yeah, zap. I mean, what do you want me to do? Yeah, nope, zap. You want to see sparks? Let's see some sparks there. I'll do it near the microphone. Hold on. There. Look at the broken fuse indicator being like, "Hey man, what are you doing? That's not right. This fuse is broken. It's not broken. It's broken. It might be. Oh, it's stuck. Okay, and now it's broken. It's not broken. No, it is broken. No, it's not. Yes, it is. No, what? Zap, zap. Okay, I think the protection circuits are working. Let's zap some more. Yeah, no. Nope. Oh, it almost got stuck. I feel wrong doing this. Okay, let's give it a bit. Let's have the PTC cool down. Okay, PTC is cooled down manually by QuinRobot with blowing air. Go. Yeah, okay, that was it. So you quickly see the other protection kicking in on the sender board, because you see that the LEDs for the pairs are dimming, and then this one takes over, and ow! Yeah, this is now 100 something degrees. Yeah, this is through the buck converter, yeah. But it's the PTC here that's limiting. So this one is now shorted, so not providing any power anymore. And we can see that by this little LED here. No, do not touch the PTC. Because here you can see the buck converter is providing power, but it's not, you know, my circuit isn't allowing it through. So yeah. And now it is. And now it isn't. And now it is. And now... Okay, I'll stop. So that seems to work well. Disconnected? No. It's still here. Yeah, I can turn it off. And you see the LEDs for the wire turn off immediately. And these will slowly die down because there's no load. So you have to have capacitors that are draining. Who knows, Philip? Who knows? Yeah. So I think this live stream for this little mini receiver version here is, or this prototype build, I guess I should say, has done quite well, don't you think? And as long as we don't draw insane amounts of power over cables that are long enough to reach your neighbor's neighbor, I think we'll be fine too. Come on, I want to get this screw in. Thanks, Sir Merlin. Yeah, when working with these kind of voltages, I'd better make sure it's safe. I have to share secrets again? Aw. But let me think of a secret. I don't know. Did I say at the beginning of the live stream I had a secret? I don't remember. Yeah, but with extended PoE, they're only doing like 10 watts, not 80. Yeah, but I don't remember what it would be. I'm trying to think of it. I'm AI generated. Nope, 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 nope. Nope. I don't remember. I believe there was something, but I don't remember what. Oh, I have lots of stuff in the works. That's no problem. I somehow doubt that they're BIP Solar Bear. I don't know why. What projects are you working on now? Well, you just saw one. This guy. Oh, that's right. I remember. Hold on, hold on. I need to get another box. Let's turn this off because it's making noise. This also worked very stably. The oh, my hair. I need to go to the barber. This also, like the output from this guy to the Dig Quad and everything here worked perfectly stable the whole time. That is very cool. That is very cool. Right, let me get another box. Okay, this is not a one-handed box. Oh. 12 volt, well, yeah, you can select 5, 12, 24, even 36 volts out if you want. That's all fine. So, I already showed these on QuinBox. Here, for instance, we have a Meanwell 55 volt out power supply. This is not the secret yet. So this will do 120 watt max, so that's a good pair with the Sender 1, which will do about 100 watt, right? So that's a Meanwell version. Then I have some Chinese versions, which are significantly lighter. This will do 52 volts. That should also work fine. And this one will do 55, 2.5 up. This is even lighter. But so these you can understand why I would have these for the Sender 1, right? Because these will apply about 100 watts of power on the Sender 1 with 55 volts, so you can run that setup. It'll also power your ESP or your Dig Uno or Dig Quad or Dig to Go or whatever. That makes sense. Okay. But then why do I have these? Oh, this is a S1500-60. It'll do 60 volt, 25 amps out. So, why would I need a 25 volt 60 amp power or 60 volt power supply? Or this guy, this is a 1500 watt 55 volt out, 27 amps. Why would I need that? Well, that's because next to the Sender 1, the Power City Hall, yes. Next to the Sender 1, I am currently working on a Sender 8. So that will be part of the Dig Octa system. So basically, instead of a normal power board, you'll get a Diff-Power board, or a Power Diff-Power board, I guess, and that will send out the 55 volt and have all the logic for sending it out at the distance, etc. So then you can take a brain board and you can hook it up to 55 volt through the power board, of course, and then you suddenly have a Sender 8. So you don't have to have multiple sender 1s. You can just have a sender 8 with 8 UTP plugs on there. And then you can have multiple receiver and receiver minis, like, you know, where is it? So the mini guy we looked at today, you can have some of those. And you can have some of the bigger ones, especially for running 5 volt. And then you can spread those around your house or your garden or wherever you need them. You just run a UTP wire, and it doesn't really matter much how long it is, except if you maybe exceed 100 meter. You have 1500 watts behind that, and you can power all your LEDs all over your home from a single board. And you can even use your patch panel to patch it to where it needs to go, etc., etc. So that's one of the things I'm working on. So I guess that's a secret. Right? So the power diff system, or the diff-power system, or however we want to call it, is going to get multiple boards, and it's going to be combinable in a Dig Octa stack to make a nice central controller with which you can run lots of LEDs. Well, not for you, Philip. But you're the CIO, so CEO. So, I mean, if it would have been a secret for you, that would have been bad, wouldn't it? I mean, how would that work? Juicy secrets! Oh. I don't know any juicy secrets. Yes, you can. You just need to make sure you get LEDs that work with the varying voltage. The Dig Quad itself is no problem. Currently, I don't have a plan for the quad. But what you could do with the quad is you can run one or two channels locally, and then have a sender 1 for one remote channel, for instance, that you also want to have power. You'd have to have an extra 55 volt power supply and things like that, but yeah. We are still planning to move, but we're trying to find some land to build on, and that's kind of the crux. So exactly, Phil. Well, the normal diff system can already do that, of course, that you don't have to have your controller in a spot that you don't really want to have it. But with power diff, it can also do the power. You still need something there, right? So even this guy, if you have 12 volts, you can do 5 amps, for instance. Or, well, you can do a few amps of 24 volt too. But you still have to have something there. But this might be a lot easier to hide, and there's no AC, and it's fully protected on all sides, etc., etc. This setup is for 1 data output per cable. Yes. What? Yeah, exactly, Philip. But this is for 1 data output per cable, but with the sender 8, you could have up to 8 data lines going through 8 different UTP cables. But you could also use 6 or 4 and use the other 4 for power injections, for instance. Exactly, Timothy. You just, you crimp a UTP cable, this is 50 meters, to whatever length you need it. These are also manually crimped. This is no prefabricated crimped. And this is all 14 gauge standard copper Cat5e. And you just, you throw it down there. You put this little guy in some kind of box or whatever. You hook up your LEDs and you're done. Well, I don't know, Joey. Maybe not directly on the Dig Quad itself, but maybe through Home Assistant, for instance. And thank you, Timothy, for the kind words. That is appreciated. Okay, I am getting a little bit tired. I am looking into that in the future. I've done some more 3D modeling stuff, and I am trying to get... The problems with sharing 3D models is that I have to have all my models correct. And I have to have models for everything I use, right? So I'm trying to get that correct for the newer boards, and then maybe publish some step files and things like that. All the LED projects, Timothy, all of them. So how many 12-volt LEDs could you run at full white 50% on one unit? I don't know. Let's see. QuinLED.info, Digital Addressable LEDs, power sheet, 12 volt, 100 use 35 watt. And let's say we have about 75 watt available. So you could run about 200 there. Fright Fish Fury, but it'll depend on the cables of the LEDs themselves, because you'll get voltage drop, and the voltage drop is likely going to limit how much you can run before this system does, right? Because you can only get 4 amps, so that's 48 watts, but the system can deliver 75 watts, but the string can probably only take in 4 to 5 amps from a single point. So the string itself will be the limiting factor, not this little board here. Yes, good point, Philip. Absolutely. Later, our CEO. Thanks for being here. I'm heading out too, because it's been a long night again. This was almost 4 hours, but hey, it's working. It's working. That's very cool. I can continue development. Thanks for being here, guys, and see you guys in the next video on the Discord or the next live stream. Bye-bye.